An electrical power system is a network of electrical components used to supply, transfer, and consume electric power. The power is supplied through a generation mechanism like a power plant, transferred through transmission lines and distribution systems, and consumed through residential applications. The voltage level should be measured to ensure an optimum value is transferred at various points along the power distribution system. This voltage is often very high, which cannot be measured with a conventional voltmeter. Specialized transformers known as instrument transformers are used to measure very high voltage and current along the power system. Voltage transformers and current transformers are essential components in electrical systems, aiding in the safe and efficient transmission of electrical power. These transformers play a crucial role in stepping up or stepping down voltage and current levels to meet the requirements of various applications. This video provides an in-depth exploration of voltage transformers in electrical systems. Before we dive into voltage, let's take a moment to understand what a transformer is. In the simplest of terms, a transformer is an electrical device that takes a given input voltage and changes it to a different output voltage. This change can either be an increase or a decrease in voltage by maintaining the frequency of the current. In most power systems, transformers are used to step up or step down the voltage levels. But to achieve this transformation accurately and safely, we rely on specialized transformers known as voltage transformers and current transformers. These devices play an important role in measuring, protecting, and monitoring our electrical networks. Let's start by exploring the voltage transformer, often abbreviated as VT or PT. A voltage transformer, also known as a potential transformer, is utilized in electrical power systems to reduce system voltage to a safe level suitable for low-rated meters and relays. Relays and meters available commercially are designed for low voltage, which aligns with the function of voltage transformers. They are commonly used for metering, protection, and control purposes. The voltage transformer working principle is based on Faraday's law of electromagnetic induction. Two primary windings and one secondary winding make up a potential transformer. The high voltage line that needs to be stepped down is connected in parallel to the primary windings. The secondary winding is linked to a measuring device, such as a voltmeter or wattmeter, to measure the voltage or power in the circuit. The transformation ratio between the primary and secondary winding determines the voltage reduction or increase. Voltage transformers are vital for accurate voltage measurements. They step down the high voltage to a level compatible with measuring instruments, ensuring the safety of personnel and equipment during electrical measurements. Additionally, voltage transformers provide isolation between the high voltage and low voltage circuits, protecting sensitive equipment from power disturbances. What is a voltage transformer used for? Voltage transformers are devices that are used to step down and decrease the voltage of a system to a level that is considered safe. It operates by allowing energy meters to monitor the operation of electrical connections, which may have a higher voltage than usual to function correctly. Depending on the application, it can be used as a low-voltage transformer or as a high-voltage transformer. Specifically, voltage transformer can be used as 1. Metering and instrumentation. Voltage transformers are frequently used for accurate measurement and monitoring of high voltage levels. They step down the voltage to a safe and standardized level suitable for various measuring instruments, such as voltmeters, wattmeters, energy meters, and protective relays. 2. Protection and control. Voltage transformers play a crucial role in protective relaying schemes. They provide voltage inputs to protective relays, which detect abnormalities in the electrical system and initiate protective actions, such as tripping circuit breakers. By stepping down the voltage, voltage transformers ensure the relays receive signals within their operating range. 3. Voltage regulation. In some cases, voltage transformers are used to regulate the voltage levels within a specified range. They can step up or step down the voltage as required to maintain a stable and consistent voltage supply to sensitive equipment or specific areas of the power system. 4. Isolation. Voltage transformers can provide electrical isolation between the high voltage side and the low voltage side. This isolation helps protect equipment and personnel from high voltage hazards and reduces the risk of electrical shocks. 5. Testing and calibration. Voltage transformers are used in laboratories and testing facilities to generate precise and controlled voltage levels for equipment calibration, testing, and research purposes. A voltage transformer, VT, is an instrument transformer used to detect high voltages in electrical power circuits. The construction of a potential transformer includes the following components. 1. Core. The transformer's core is built of laminated magnetic material, such as iron or steel, to create a low-reluctance path for the magnetic flux. Hysteresis and eddy current losses are minimized by the design of the core. 2. Primary winding. The high-voltage line connected in parallel with the transformer's primary winding requires periodic monitoring. The primary winding is typically built of a few rounds of thick copper wire or bus bars to accommodate large currents. 3. Secondary winding. The secondary winding of the transformer is connected to the measuring instrument, such as a voltmeter or a protective relay. The number of turns in the secondary winding is determined by the ratio of the high voltage to the low voltage required by the measuring instrument. 4. Insulation. The primary and secondary windings of the transformer should be electrically isolated from one another and able to sustain high voltages. Paper, oil, and resin are typical insulating materials. 5. Terminals. The primary and secondary windings of the transformer are connected to the high voltage line and the measuring equipment, respectively, using the terminals. The terminals need to be built to resist high current and voltage levels. 6. Protective cover. A protective cover is typically placed over the transformer to guard against environmental elements like moisture and dust and prevent unintentional contact with the high-voltage components. What are the types of voltage transformers? Voltage transformer has 3 types as following. 1. Electromagnetic. This model of transformer is comparable to the oil-filled coiled wire transformer because it uses a wire wound core. The primary voltage will be turned entirely into the secondary voltage in this sort of converter, which the use of electromagnetic would accomplish. Some applications to electromagnetic voltage transformers lie in their ability to 1. Employ in the field of electrical metering. 2. Safeguard electrical instruments. 3. Provide protection for the feeder. 4. Make generators protected from damage. 5. Establish electrification of industries. 2. Other type of VT is capacitor. This kind of voltage transformer will be equipped with a capacitive potential divider, which will be linked between the mainline phase and the ground. As a mixture of the capacitive voltage divider and a magnetic transformer, this converter can be thought of as a hybrid device of sorts. These transformers are referred to as intermediary converters with a relatively tiny ratio in the industry. This type of transformer, which is composed of a stack of high-voltage capacitors, can be utilized for voltage metering in addition to being employed as a protection system. As a result, the capacitors may reduce the voltage levels, and a transformer then steps down the lowered voltage to a supplementary voltage level. 3. Optical. Optical voltage transformers are quite a new type of power transformer that can be used for safety and metering applications instead of the usual electric-magnetic converters. Its benefits have been extensively addressed in scientific and technological literature, and its business functions have been highly acknowledged and established in the marketplace. Many electric plant operators try to steer clear of them because of the high expenses and because the technology is relatively recent. It is not controlled by local professionals, necessitating significant contracts with the manufacturers to operate. Due to the fact that it's already been demonstrated that optical innovation has its own set of benefits and drawbacks, the exploration of alternative optical solutions has become the primary goal of high-tech laboratory settings, and it is also the primary goal of the current work. In conclusion, voltage transformers are indispensable components of our electrical infrastructure. They allow us to transform and measure voltage and current levels accurately, ensuring the smooth functioning of our power systems. Without these devices, our ability to monitor, control, and protect the electrical grid would be severely compromised. That's it for this video. I hope you found this explanation helpful in understanding the importance of voltage transformers in electrical systems. If you have any more questions or topics you'd like us to cover, please let us know in the comments below. Don't forget to like this video and subscribe to our channel for more informative content.